Thank you, Andy. That was quite generous as an introduction. And welcome, everyone. Good evening. Thank you for being here. It's a warm evening, so we are looking for some nice warm discussions with our expert speakers. It's really a great privilege to be chairing this panel on Retrofit Meets Innovation. As I said, we have excellent speakers who have not just a depth of experience in retrofit and innovation, but also quite a wide spectrum of views today in terms of how innovation is changing and accelerating the retrofit landscape. So we will hear from them. And we all know that innovation plays a critical role in retrofitting. New technologies, solutions, tools, and approaches are helping accelerate action on energy efficiency, on sustainability, on retrofit materials and methods, but also helping us monitor the impact on both the building health and the health of its occupants. So this is particularly important, I'd say, considering the theme for this exhibition, which is what's stopping us. We'll hear today on some of the great work happening in this area. And we know we need healthy homes for everyone. And this is increasingly, when we talk about healthy homes for all, it not only means warm homes and affordable homes, but it also means climate-adapted homes that are cooler in the summer. They have good air quality and noise suppression. And they're also supported by good quality connections to communities and services, green infrastructure, and so on. What makes a place and a life healthy. So just to say, at Connected Places Catapult and other partners who are supporting this exhibition, this is very much the direction we see that retrofit is moving. We're moving much more towards place-based regenerative approaches. And here we will hear from some of the great work, some of the data processes, tools, solutions, and innovations that are helping us get there. And with numerous smart technologies establishing in the market and the sector recognizing the importance of retrofit in achieving our ambition of healthy homes for all, what is the role of innovation in this market? How is this changing? So without further ado, or rather shortly, I'll hand to our speakers. I'll just reiterate, bring your questions, and this is very much a discussion, and look forward to your thoughts. So I'll hand over to Laura first. Thank you.
So as was Anne said, I'm from Innovate UK, and thank you. As the name suggests, we're quite keen on innovation. We're the government's innovation agency, and we spend public money to try and help de-risk innovation in the belief that the UK will create solutions to the challenges that we face, and then those businesses will grow, and those businesses will be able to export their solutions elsewhere. The programme I work on is Net Zero Heat, and our ambition is all buildings off gas for their hot water and space heating. And we start from the premise that we basically have the technologies we need to do this. The problem is that the rate of uptake of those solutions is far too slow. And we've identified the main problem is trust. There's not enough certainty in what retrofit is going to do for our buildings. And so there's a sense of inertia, and people aren't investing in retrofits as fast as we would like them to. So we work in these three kind of work streams, three types of innovation. The first is data innovation. We think we need a shared understanding of our buildings, what they can do, and the systems that can go into them. And then we can understand what the impacts are of making the investment in those retrofits. The next one is technology innovation. So we know there are solutions out there, and actually we're going to hear from two companies today who have good solutions that aren't being used as maybe much as they should be. And so with the technology innovation stream, we're thinking about how we can overcome the barriers to that rollout. And then the last type of innovation is process innovation. We'd like retrofit to be a more industrialised process, more standardised, so that we can bring down cost and make installation and those works much easier. So we give out our money often through competitions, grant awarding competitions. And we've had a number of these, particularly focused in the data innovation stream. The first of these was about getting data from buildings, getting data from systems, and allowing a user to understand their portfolio of buildings and how they could decarbonise across that portfolio. And 4 projects came out of this competition. The one on the screen is Quantico, which is for non-domestic buildings. And they're able to bring together information about a building, information about data from lots of different technologies that you might put into that building, and work out an optimised decarbonisation pathway. So it's putting data into the hands of people who need it and can use it to make decisions, including investors and management, and they're able to bring in things like planned maintenance. So you're not getting rid of a boiler prematurely, wait until its lifetime ends, and then you can make the investment in that new heating system. An important part of this competition was that there was feedback loops, so that the 4 tools are all using data continually to learn what the best advice is that they can give. So the next competition was about understanding the performance of buildings better. And we think that this should be done on a more regular basis, building performance evaluation, testing buildings to find out what's really going on in them. There were 8 live projects. There were 8 projects in this competition, and these are just 2 examples. So Kestrix is using infrared images from drones. They are able to scan across portfolios of buildings and give a portfolio owner information across their stock. So they've worked with the Peabody Trust during their pilot and development project, and Peabody now have this sort of rich database of information about the thermal performance of some of their houses, and that enables them to make good decisions. It's also giving them a bit more certainty that they can pass on to their supply chain, and that's really important for bringing down some costs, because when they sign a contract, often that risk of, okay, how many houses are we really going to do, is built into the cost, and Peabody are paying for it. So having more data is enabling them to make better informed decisions, but also their supply chain can make better informed decisions. And then this is another technology which is used to find the air leakages. And it's portable, which means that you could, and easily use. So it could be used repeatedly during a retrofit process, understanding the building at the beginning of the process, what needs to be done to fix its air tightness, perhaps during the retrofit to check what's being done and what's been achieved, and then again at the end proving what's been achieved. And this is all building trust in the retrofit process. Our next competition was focused on process innovation. We actually did something quite unusual for Innovate UK, which was an innovation lab. We took away 40 individuals from different companies. And we did that because we wanted to see new collaborations formed. So people talking to people who they wouldn't necessarily know or collaborate with in the past. And we wanted them to think about how the whole retrofit process could be better, more streamlined, more industrialized. And we wanted them to really think about the people who are living in a home or people working in a building, so that process is better for them. 3 projects came out of this. They're still ongoing. One of them is Let Zero, which is focused on the private rental sector, and it's led by South Yorkshire Combined Mayoral Authority. Another is called Transformer. They are looking at a kit of parts process. So how can you bring together different components from different companies and understand the archetypes that are suitable, that suit those technologies, and identify where those archetypes are. So they're using data to understand, again, portfolios of buildings or retrofit opportunities at scale. But they're also looking at the finance and the contracting. So again, that's making the retrofit easier. Rather than having to go to lots of different contractors to make your retrofit happen, you can go to one group who already understand each other and understand their technology and know how they'll work, and they'll know how they'll work for the building archetype that you're dealing with. And then the last one of those in this competition was Alchemy, which is focused on non-domestic buildings. And they're doing some really interesting stuff with the way they present data about buildings, but also how they visualize the retrofit, which I think is really useful for engaging people. So if you've got, for example, a historic museum is one of the buildings that in their pilot, it matters to people what the retrofit will look like. Where is the heat pump going to be? And there are practical considerations like figuring out the space where it's going to be, and having that model of a building helps with that. But also for engagement, having people understand and be willing to go through with that retrofit is really vital. This is just to mention a report that we supported. So Innovate UK has done work in retrofits for a while. There was a big gap, but more than 10 years ago, it was the Technology Strategy Board funded retrofits when we were trying to get to 80% carbon reductions. And as part of that, there was quite a lot of monitoring done and building performance evaluation. Last year and the year before, a team went back to 10 properties, so 10 years on from their retrofits, to see how they performed. And the reason for this was we wanted to show people that those retrofits had worked. They worked at the time and they still work now. But we also wanted to understand what the progress with building performance evaluation technology looked like. So how easy is it to actually understand that building and get the data that you need to understand it? And again, build the confidence in the retrofit, because you've understood your building and you can understand what happens with it. And the report was very positive on the retrofits, and also very positive about how building performance evaluation has moved on. So I mentioned technology innovation. These are some of the companies that we're supporting. So Sunamp, you're going to hear from later, is on the list. They offer a wide range of technical solutions. All these companies have actually had Innovate UK or UK government funding in the past to develop their ideas. But what we found was they weren't being taken up as quickly as we would like. And this is something that Innovate UK monitors. How do the businesses that we fund, how do they grow? How do they employ people, and how are their sales? So it's really important it was important for us to understand why they weren't really scaling out. And so we brought together this cohort to tell us the reasons. And what we found was, for a lot of them, it was because they weren't included in SAP calculations, which meant they weren't included in EPCs, which is obviously a very important thing particularly if you're getting funding. So at the moment we're working with these organisations to help them, but we're trying to help them directly while actually trying to change the system a little bit, shift the system so that instead of only suiting the incumbent technologies, heat pumps, and previously it would have been boilers, it may now be heat pumps, but we know that there are these solutions and there are other innovations that will come along, and the current system doesn't easily bring them in. And that is leading to them just not being bought, despite the fact they are good solutions that solve real problems. I think I'm probably going over time, so I'm just going to mention two big data things that we've been funding. This one is about scanning buildings to find out their condition. We need a bit more information about buildings than EPCs are currently giving us, or a bit more accuracy around it. The XRI are creating a massive database of building condition, and with our funding, that means that some of that is going to be openly available. And the reason we do that is because we think that data can be built upon by other businesses, layered up with other data sources to create new solutions, particularly around decision-making for retrofit. And I'll just mention Live Data Trust, who are another organisation who are looking at how you share data. So we know there's lots of data out there, but it needs to be shared so that you can do this kind of layering thing and find the best solutions. And again, we expect other businesses to build on top of that technology and find different solutions for different problems. And that's us. And all the time we are trying to think about why we're doing this. It's about giving people affordable heat in their homes for their health and well-being and their productivity. Thank you.
Thank you, Laura. Over to Andy now from Sunamp.
Yeah, good evening, everybody. I'm Andy MacCullum. I'm the Regional Sales Manager for Sunamp. We're an Edinburgh-based company, and we create thermal stores for hot water demand in retrofit and in new applications. Brilliant. So, there's some props today that I've handed out that you might see just to go through the technology that we use. So, you'll see in front of you just a hand warmer, probably the wrong sort of day for a hand warmer. If this was November, I think they're quite handy, but it's to demonstrate what we use to store the energy. So if you think of a hot water cylinder, a standard domestic hot water cylinder, where you'd store that energy in water, effectively we're storing that energy in phase change material, or in this case, Plenty 58. So at 58 degrees, this product, if you clip the hand warmer, so just to demonstrate that latent energy storage, they take a little bit of clipping. I'm sure you've seen them before, but when we see that change from a liquid to a solid, we can feel like heat being given off. That exothermic reaction is generally what we harness in the product. So to turn that back, once our heat's come out of it, as you can feel, we run the cold water or the hot water that it will be through it. It picks up that energy exothermically, and then you get instantaneous hot water. But we charge this at a time when it's economical, or overnight on a low tariff. To turn this back now, we need 63 degrees. So a heat pump, ground source, loop, electric, solar energy, whatever it might be, we just ask for 63 degrees to change that back. As that then melts back to a liquid, what happens with it's sodium acetate trihydrate is the chemical, which is food standard salt and vinegar. It's nothing. It's not corrosive. It's not harmful. Not flammable and fully recyclable. So there's no nasties in there. That changes back to a liquid, and the properties of it stores the energy 4 times better than water. So what we end up getting, you can see from the unit over under the stairs in the open house there, is a compact thermal store, if you like. And then there's some benefits that we see off the back of that. So that's just a bit about the technology that we use. We can see within the element, this one's a direct version. So we've got a cold feed coming in, and then a hot feed going out. The blue portion of it, which would be your water, it's actually this phase change material. So if you imagine the box filled with the Plenty 58, we run a heat exchanger through it, and we deliver that hot water instantly. Just go into a bit more detail about it. We can see there 35. We were talking about innovation and how it's a trust thing. We've fitted 35,000 of these units now across the board, across the globe, really. So it's tried and tested. Some of you might not have heard of it, but it's one of these innovations that we think really solves a solution. So we'll talk a little bit more about it. So we can see this example is, we say heat agnostic, if you like. So long as we can generate that 63 to 65 degrees to melt that formula, to make the energy storage happen, we don't necessarily worry about where it's come from. So if it's a gas boiler, traditionally, we can use it paired to a traditional system. If we're moving towards a heat pump, solar, we have an element in the bottom, an embedded element that sits in there that we can use for grid electric or solar. So it doesn't worry about where that energy is coming from. It can work alongside, again, Ethan will talk a little bit about his product and space-saving benefits of that. But an electric, radiators, heat batteries, whatever it might be on space-saving, we can do the hot water side. I think in retrofit, the statistics, I think 20% of the time, retrofit can be problematic on the thermal storage side. And half those times, it's space that causes that issue. So if we look at the images, so I come to you, over on the right, we can see the 4 pipes. We have 70 litre equivalent. It doesn't hold 70 litres. It's a 3 kilowatt store that we talk about water delivery. So we have a 70, a 150, 210, and a 300 in the range. 300 is about a metre high. The unit over there under the stair cavity, I think, is a 150 unit. So you can see 2 or 3 steps up. We're looking at retrofit and being innovative. That's somewhere traditionally, you might put it in an airing cupboard, but we're saying maybe rethink it and put it somewhere else, under a unit, under an 800. kitchen unit or any utility. So it's given that flexibility on where it can be installed. So yeah, the image on the right, that's up at our innovation centre in Edinburgh, and it tells a story that I've been trying to discuss tonight. But you can see on the left a traditional hot water cylinder, and then on the right we can see the Firmino thermostor. So space saving goes without saying, that is our biggest USP, and because of that energy storage, up to 4 times smaller than the equivalent cylinder. So the image on the right there is a 150 unit, and it's equivalent size of a cylinder. So you can see the space that is saving, and the cube gives you that space as well. We're getting fast flowing mains pressure hot water on demand as you would, so that performance is still there. But the design, because it's almost instantaneously heating that water up, it's under 15 litres of stored water. You've just got the water within those pipes that we could see on that first image. So there's no Legionella threat from it because it's under that threshold of stored water. So that's, a benefit, but also an energy saving on the pasteurization that you don't have to do with our product. Low maintenance, so there's no moving parts on the unit. There's no pumps. It doesn't need a clearance. You can see it needs maybe 10 mil clearance. There's no fans or moving parts on there, so it'll fit into very confined spaces. And again, going back to that retrofit question, that's a challenge that we can overcome. Oh, that's up. So yeah, some of the benefits and the role of thermal storage, individual properties. We can add solar PV at any time. So the unit straight out of the box will have that element in it and be electric ready on a low tariff or an overnight tariff, but you can add solar PV to it. So we're on a 5th generation product now. So instead of having maybe a PV version and a non-PV version, we've simplified it. With the addition of an Optimino key, which just goes into the control board, we can then make it ready for solar after the event. So if it was a case of pairing it with a standard boiler, taking advantage of solar at a later date, and then potentially changing that energy source further down the line, it's not a case of ripping it out and changing it. It's a case of just changing that key with the sort of information on there to let it know what it's connected to. So it's that future-proofing of the product as well. If we look on a wider scale, managing the grid off-peak, that demand-side response piece, we can do that easily with product. The 300 litre equivalent is a 14 kilowatt-hour store, so it's a good benefit. It's a good deposit to put that solar energy into, and then allowing renewable energy on a large scale to be stored when it's permitted, and then hot water as it's needed on demand. We know we're sort of in this day and age, we are washing more. We're more clean, I think. So the hot water demand within a property has become that bigger element of the energy being used. So having it ready and stored at the right sort of price is really, really relevant. But finally, just some examples. So where we've used the product, private, domestic, small properties, we can see the savings there per month that were in the north of England. This was just the installation of a Firmino unit with a heat pump. We'll see the savings there. Social housing, this was some of the projects we've done with another partner, I think, Kenza Heat Pumps. So this was degassing tower blocks. So it was a combi boiler out, and then a ground source shoebox unit going into that combi space. The problem then was, where can we now fit the cylinder? So as an enabling product, we enabled that project to be able to take place because there just literally wasn't room for a cylinder. So the Firmino unit went into a small 400 mil cupboard and was able then to take advantage of the ground source and all the benefits that gave. So as a keystone product, it opened up that 67% saving to the tenants. So it was a real bringing in other technologies. Holiday lodges, so on the leisure side, hot tubs, obviously a good way of storing large amounts of energy. We can daisy chain, if you like, the product together. So if it's that we need more than 300 litre storage, we can just simply put them together. So that was an option as well on the holiday lodges. And then sports facilities. So this was Bonnyrigg Rose up in Scotland, where they had solar panels. They wanted to store that energy and get away from their high gas usage. So they were able to do that with the unit as well. So it's flexible on what it can achieve, but also very simple. Say when you go back to the phase change, it's a simple concept. We're quite a passive product, but we fit into a lot of the technologies and allow us to take advantage of those technologies that are out there. And yeah, that's it for me. Thank you. So
You want to pull the I said, well, this is the screens, isn't it? Yeah. So, no. Yeah, thank you. I mean, this is such a good demonstration of kind of how space saving really, and how something on a retrofit solution links to quality of life. And I know we're going to continue that theme with Ethan. So yeah, I invite you here.
Thank you. So, thanks very much for having me. So my name's Ethan Wadsworth. I'm one of the directors at DiscreteHeat. DiscreteHeat are a manufacturer based in Manchester, and we manufacture thermoskirt, which I would invite you to go over and have a look at later on. It's installed over there. Thermoskirt is an alternative to radiators for underfloor heating that works on new and existing heating systems. So before I start trying to operate this temperamental clicker, which could go in any direction, this presentation can go in any direction now, just by show of hands, who in this room believes that heat pumps are a viable way to heat a house in 2025? Some hands down, so you're saying they're not viable alternatives. Okay. You think they are? Keep your hands up if you've got your hand up, right? So I'd say 80% of the people with the hands up, keep your hand up if you have one heating your house. If they could. Okay. So retrofit, what's stopping us? There's a £7,500 grant going, by the way. So did you know that? Yeah? Right, so it's not the money then. So we keep trying to solve problems by throwing cash at it. And I'm going to explain to you now why it's not always the money. Key benefits of our system, if it's not already obvious, primarily is aesthetics. So, as a nation, we've kind of got used to radiators. We expect to see them on our wall. Fair enough. We're not necessarily thrilled to have radiators that are 2 or 3 times the size of a standard radiator, and that is a major barrier. Obviously, usable room space, which Andy's mentioned. Bigger radiators also impacts the usability of a space, the flexibility of a space, and how that space can be used. And then obviously efficiency as well. In order for any kind of new heating system to be viable, it needs to be as efficient as possible. And that generally means making the flow temperature as low as possible. And those two things are directly aligned. Okay, how thermoskirt helps enable the rollout of heat pumps. So in terms of major works, which I'll come on to, it reduces the amount of mess, basically, that's involved in retrofitting heating systems. Home improvement, so there's a perceived lifestyle benefit to having no radiators. People generally pay more to have either no radiators, underfloor heating, for example, or nicer looking radiators like designer radiators. And rolling in perceived lifestyle benefits helps with adoption, because if there was a £7,500 grant for heat pumps, if there's a £7,500 grant for hot tubs, they'd be flying out of the door because it's a lifestyle benefit for most people. People generally don't see heat pumps as a benefit to their lifestyle, so there's no sort of intrinsic motivation to actually have one, other than the fact there's a bit of free money floating around. Obviously, I live in an echo chamber where everybody loves heat pumps and they think they're great, but on the outside world, people aren't. So the barriers fall into four sort of primary categories. One is obviously insulation. Insulation needs to be improved to make low temperature heat systems more viable. Fundamentally, heating systems offset the heat losses that the fabric can't. Okay, so the worse the fabric, the higher the heat loss, the more the emitter has to do. If the heat loss of a property is 0, I wouldn't even be here because emitters wouldn't exist. We wouldn't even need to be here. Unfortunately, that's not the case. So improve insulation as much as possible. Check, and that has obviously been done a lot over the last 25 years. Cavity wall, internal wall insulation, additional loft insulation. There's been incentives running on insulation for decades. You've then got hot water storage and radiator sizes, which are massive. Hot water storage especially. Most houses in the last 30 years have been built with combi boilers in mind, and that means that they haven't generally been built with airing cupboards. They generally haven't been built with storage that allows for addition of a hot water cylinder. New build developers generally, not all of them, but generally, they try to get the biggest bang for buck and sell the house for the highest profit margin, and that generally involves removing things like garages, removing things like storage space. And that makes adding hot water cylinders to existing properties very, very difficult, like Andrew covered in great detail. The other thing is radiator sizes. So radiators need to be upsized significantly, and most people in retrofit situations don't fully appreciate how big they actually have to be. You're not talking about a 10 or 20% increase. You're talking about a 2 or 3 times increase. So the correction factor on a radiator that's running at 70 degrees to a radiator that's running at 40 degrees is 0.3, which means that if it's a 1 kilowatt radiator, it's now a 300 watt radiator. You need a radiator that's 3 times the size, which basically turns most people off the idea of having a heat pump. And finally, you've got micro-bore pipe work. So 4.1 million homes in the UK have micro-bore pipes. Micro-bore basically delivers less heat down it than a 15 mil pipe. And when you lower that flow temperature, it can take you below that level of being able to deliver heat. And that basically, in simple terms, means that if you want to fit a heat pump in-house with micro-bore, it's a completely new heating system. It's not even a case of swapping the radiators out for bigger ones. It's a gut job. And so you then go from light retrofit into deep retrofit territory, where you're having to chase pipes into walls and find new locations for pipe work. And this will all get joined up in a minute as to how thermostat. And just to reiterate the point, this is the size of the radiator that would be required for a certain heat loss. So a typical living room is in an apartment, for example, could have a heat loss of 1 kilowatt. A 1 kilowatt radiator is 2 meters long. It's a 2 meter by 600 high double panel radiator. So in some circumstances, in apartments in particular, there aren't even walls available for radiators of that size, which then means you need multiple radiators. And if you go from one to multi, it's new pipework positions, it's branching off pipework, and again, you're moving into deep retrofit space. So, I probably could have condensed 4 slides into it's a pain in the arse to retrofit heat pumps, basically. It's messy. And obviously just look at it. I mean, I haven't got radiators in my house. I've got thermostat, obviously. And once you've removed them from the house and you've refurnished, you cannot imagine putting them back. And for the last 15 years, every house that I've been to is either about to remove their radiators or has removed their radiators. So, it's a bit of a nightmare for my wife because we're watching TV and I'll spot them. And I'll be like, oh, look at that. I go through life just noticing radiators. It's really sad. Don't go through my camera roll on my phone. It's really, really dull. It's just pictures of skirting boards. But that's what you're faced with, basically. If you're not going to go longer, you have to go deeper. So K3 radiators have always existed, but you've got K1, single panel radiator, K2, double, and K3. K3s stick out the wall about 250 millimeters. So you're basically installing a breakfast bar just to get a heat pump to work. In terms of the plumbing that is involved, thermostat is a radiator. So this is one of the challenges of innovation, is that if you package up a product in a different way, mentally, people then have to make a leap that it's now a totally new system and there's some sort of witchcraft involved, and how could it possibly work? All it is it's a radiator that has been squashed and stretched out. And if you chopped up all of your skirting boards in your room and you stacked them up high, it would be about the size of a radiator. It's as simple as that. It's just surface area, water volume, and heat distribution. Yeah, make sense? In terms of the distribution of pipework, it's the same. So you've got a standard flow and return, and that's branched off to each thermostat system. It also branches off to radiators. So in some retrofit applications, there's 2 solutions here. One is, rather than throw the baby out with the bathwater and replace the radiators, I mentioned, say, a 1 kilowatt radiator now becomes a 300 watt radiator. You have a 700 watt shortfall. You can leave the radiator in and add the thermostat on to the existing system to make up that shortfall. So it has to do less, it's less cost, it's less invasive. You're effectively using both systems in tandem, they work together. The other way is that because insulation has improved over the last 30 years with things like loft insulation and double glazing, if you take my house, for example, when I moved in, the radiators that were there were installed in the 70s. And when the house was built in the 70s, it had single glazing and no loft insulation. So those radiators were actually oversized, way oversized. So we're now used to walking in from work and going bang, and our heating system goes basically, and brings the house up to temperature in about 5 minutes. That's because most people's central heating systems are massively oversized. And if you were going to do anything to save money on gas, obviously it's summer, but come winter, I would just turn your boiler down from 75 to 55 and see what happens. If you aren't uncomfortable, leave it there because you'll save about 25% on your gas. So fundamentally, the point of this slide is thermostat is a radiator. Okay. The challenge we've had to overcome is explaining to people that it is no different. And that goes right from the top to the bottom, from MCS, SAP, like you mentioned, Laura, these governing bodies that see products as different when in reality, the physics is exactly the same. They are the same. Look different. So retrofit disruption, Energy Systems Catapult, this is run in 2023, published in 2024. Disruption was 68% of participant dropouts. It says economic reasons was 4%, which I don't believe. I don't believe that because if you were given the option, is it too expensive or is it too much disruption? Most people are not going to say it's too expensive because it makes you look cheap. So I don't believe that 4% is economic. I think economic is actually more significant than that. However, practicality and disruption accounted for 83% of heat pump dropouts, according to Energy Systems Catapult. And that basically means that somebody who's inquired with OVO Energy or Octopus or anybody else who was involved, and they've basically said, I want a heat pump. They've gone out and explained what's involved, and they've said, I no longer want a heat pump. Okay, so we help overcome and address that in that format. So that's the heat distribution from a radiator, and that's the heat distribution from thermostat. You can see the difference from the same energy input. 800 watts being delivered on the left, 800 watts being delivered on the right, same amount of energy, same heat loss, same room, and totally different outcomes. So people get more comfortable homes as well. So final couple of points here. Get extra time because the clicker, right? Is safety. So obviously health and safety is a major concern. Believe it or not, this is the accident statistics for radiators. There's like a proper hit job on radiators, this presentation, but this is the accident statistics. The bigger they are, the more dangerous they become. So we do a lot of work in healthcare for that reason. And finally, mold and damp prevention, which is a major issue. Obviously, we've not got anybody on the panel tonight who's specifically involved in ventilation, moisture control. But people have a tendency to dry clothes on radiators. And when you make buildings more airtight and you seal around the windows and you reduce the natural ventilation, you then increase the moisture levels within the property, which has to be managed. When you install bigger radiators, you can fit more laundry on them. Okay. So there's a secondary impact, which is you then have mold and damp appearing, which is another thing that we design out. So there's a whole myriad of cascading benefits to simply moving away from the status quo, as it were. And I suppose that's one of the issues that us as innovators has to overcome with case studies like this one, where they took a 1950s council house and brought it up to modern standards with solar and heat pump, batteries, and thermostat, made it safer and cleaner. And of course, go back one, no one's interested in that or that. Good. There you go. So that's the example of the thermostat being used in addition to radiators. So anyway, I'm sure on the panel we'll be answering those questions. So thanks very much, everybody.
Thank you, Ethan. And without further ado, over to John for providing the big picture. I suppose again, like English.
I'll see if I can get this working. So yeah, this is me. So just to introduce myself again, I'm John Ackroyd, co-founder of Ackroyd Lowrie Architects and a director there. I thought I'd start off talking about innovation by actually going slightly counter to it, because we're here to talk about retrofit and what's stopping it. And I think a lot of the time what's stopping it is the narrative around it. We're often talking about the issues of just technical solutions, whereas I think it's really important to think about actually the bigger picture and why people want to live in retrofits or work in retrofits and what it means for our cities of the future. So about that interplay, and here's a sort of poetic quote from T.S. Eliot about that kind of interplay, bringing back things from the past and bringing forward things from the current point that civility moves forward. So So I think we all know about the growth of our cities. As I said, I'm very interested in the future of our cities and how retrofit fits into that. And what we're going to see over the coming years is a massive, massive increase in the population in our cities, alongside the challenges that we know around climate change, biodiversity, etc., and increasing heat. So what is that actually going to mean? We know we're going to be more dense, probably. And if we just keep pushing up and just keep getting taller and putting new buildings in, they're going to get incredibly hot and incredibly busy, as we've probably seen today. So I think, for me, the interplay in creating kind of retrofit buildings and connected retrofit buildings is so important about the future of our cities. So I think we've got to remember that argument when we're thinking about it, and then not just talking to people about spreadsheets, because I think that only works for some of us. It's preaching to the converted. I'm very interested in sustainability and energy, but not everyone is. And it's about the future of our cities. Oh, still one thing. I picked up a proverb, which is just about, we will often talk about a wedding and you say something old, something new, something borrowed and something new. It's about love and bringing something together. And I think that's the best retrofits that I've worked on are about that. It's about bringing something together and bringing something special to the city. We're seeing that kind of innovation happening in our cities at the moment. So in Paris, this is just a scheme that's going ahead to kind of reconsolidate the centre of the city, celebrate the old buildings and bring in kind of new interventions and greening to kind of make those city spaces work. We're seeing that in Oxford Street. There's been a lot of debate about retrofit on Oxford Street. This only a couple of days ago, the new pedestrianisation of that and celebration of those existing buildings, I think is really interesting. So, hello. When you think about some of the best buildings that I know, the Sustained Chipperfield in Berlin Years Museum, there's that interplay between new and old, and that journey that actually makes some of the best buildings that we know. This was Foster's in this city, and Truman Brewery, which some of you know. So that was a real success of taking old buildings, bringing them back into life to create amazing space. So in terms of what we do, this is an old building in central London. We took an old kind of warehouse space, we created it back into being one of the leading fashion photography studios in the country. And actually here we could have knocked this down and rebuilt it, but actually the client wanted to retain that. And that was a very interesting space and created something that is very special. So in terms of the innovation, after sort of framing our thing, what are the things that we're doing and we're seeing that are changing in that innovation retrofit space? Upward extension of existing buildings. This is key. So this is a project we've just got planning permission for. You can world, that's what it looks like at the moment. It is derelict, empty, and was actually previously literally knocked down, and a new skills thing was built. It turned out to be unviable and unsupported by the council. So when we were brought back in to work on this scheme, we suggested a retrofit, keeping the whole building, extend it by up to 5 stories, saving over 4,500 tonnes in terms of carbon embodied through the building itself. But here's become an argument out of her. But beyond that, we actually supported and developed to create a green network connected to Canberra Green to the FI, and therefore kind of create something that it's, although we're creating density, creating a new public plaza, public space, and linking that together. So how does that link to innovation? How do you get that additional height into your building? How do you do that quickly? There's loads and loads of buildings around the UK at the moment. And how do you quickly understand? It's quite complicated. So one of the tools and the partners that we work with are called Optoppen. It's all about kind of extending upwards on buildings, and they have an online platform with Wood engineers, and basically allows you to quickly test that they're developing a platform so which buildings can actually extend upwards. So it's a really powerful tool because actually there's due diligence in the process. How we start using something during is how we extend upwards. So I think that's a really interesting platform for people to look at. So in terms of Scottish upwards, you look at inwards extension. So this is the City of London, a small building in the heart of the city, just off Lime Street. And really here we're looking at taking a building that is very inefficient, but we couldn't go much higher because of various fire constraints, some things, but we tried to improve the efficiency of that building by about 50%, by distinctly kind of
reconfiguring what was doing in the primary structure. As well as that, as we've gone through it, the building was rebuilt in the 70s, but not fit for purpose now. So we actually found a bit of old Roman ruin that was actually sat in the back of the building. So we incorporated that into the front of the building. But what was interesting here in terms of innovation, we're actually keeping existing structural slabs here fit in the 70s. So these are concrete, metal decks with concrete infill on it. And actually what we're doing is that in existing tanks, we're actually, rather than knock out concrete floors, which are not exactly right in some places, which is a common problem in retrofit, we're actually moving up entire floors with sort of basically the steel bolts broken, and then actually the whole floor is pushed up and lifted, so that this new building could have a completely different life with a double height stage, so we possibly be able to done before. And that's a big construction we play in SD structures, so really exciting and moving forward at the moment. And then another part that we work with is more a development manager. And what they do is look at data driven design, as we talked about before, and how you can really analyse buildings and understand them better. They're particularly interested in the reuse of the M&E, and actually how in a lot of office buildings and commercial buildings, we tend to throw away all the M&E when you retrofit. It's sort of usually effort of designers and the contractors, and actually if you look at it, a lot of it's actually serviceable. And so what they do is do really detailed strategic analysis early in the process. And they do data analysis of the existing systems, and they kind of look at the sort of 80-20, well, what can we do? And actually surprised when you're struggling to make things work financially, that can offer a framework that's really forward building that wouldn't otherwise work. And often it forms part of a phase of sort of development or part of one of the strategic portfolio like this. So we talked about how to scale this. So how do we make more innovation happen? I think for me, just coming back to what I said at the beginning, it's important to reframe the narrative and meaning. We find when those buildings are doing, keep some of the history, we keep some of the new, it creates more value. And that actually is important to say it's not just about technological solutions, it's about creating more value to clients, to people to need them. It's not just about embodying energy, it's about embodying meaning in those buildings. So I think what I'd say is there is a lot of innovation happening, but I think that the challenge is there isn't scalability there. And in retrofit, particularly in terms of the regulation, there isn't nationalised policies. You have it in local authority or local authority. And there is flexibility in some, not in others. There is talk of new planning policies. There was a consultation last year. There should be new development management policies coming out. And the London Plan are thinking about revising to bring into retrofit policies. It's not there. And I think when you don't have that scalable market, the places that basically green finance and invest in, it's very difficult to innovate. You do one or two little projects, you can't take up. You need a bigger platform, a bigger market. Insurance alignment is really key to that as well. We found finding timber and different things, particularly post-vertical, is difficult, even though they're perfectly soaked in many scenarios. So it's trying to bring together those things so that you can actually scale. Because I think that for us is where we've been working a lot on, is how you can really green finance. Some of you may have heard of the taxonomies. This is about the new green funds that can be created by green finance and how they can invest in Mexico. And so we are very keen to find those technological solutions, to find ways we can scale it in and use green finance to support that and spread better. Thank you very much.
Oops. Thank you, John, and thank you to everyone. I'm going to start with a few questions. I mean, this was just covering such a broad spectrum from the data and technology and real creating the market side of things to actual interventions in homes, to taking it again very big and almost green infrastructure and quality of life as elements that we could look at as retrofit, not just of homes, but to cities. So I'm going to start with you, Laura, if that's okay. So you've mentioned data, technology, and process innovation. I'm going to ask really about the opportunity you see as you work with different types of solutions to join up and to create a retrofit revolution that's kind of bigger than the sum of its parts. So what do you see as that space?
joining up these things is very important. Sometimes that's going to be technological. So in fact, this has already been mentioned, Sunamp works well with heat pumps. In fact, it's an enabler of heat pumps going in. Similar with the thermostats. So sometimes we need things to work together, and actually there's probably opportunities where things can work even better together. So we see some solutions where they're using sensoring and monitoring technologies to really understand the occupancy and use of buildings, and then control systems so that the heating and the ventilation to provide really good comfort. And I think sometimes this is a bit of a challenge because the focus, including in modelling, is often on delivering air temperature. And actually what we want is comfort. We want thermal comforts. So that's sort of a bit of a nuance that I think processes and systems don't really particularly deal with very well at the moment. But if you've got situations where a heat pump is difficult, and there might be various reasons for that, including affordability, there may be an argument for having more intermittent heat. So in that case, you might have, and I've heard of this in some situations where you might have heat pumps running at very low temperature as they do very efficiently. And then based on occupancy, you might use infrared heating, which gives you a boost. So, and some of those things could be really complicated for users. But that's where I think the data and interoperability can come in and be really powerful, because you could have, if these things work together, all that clever bit or tricky bit is going on behind the scenes. The occupant doesn't need to know about it. The occupant can just be comfortable. And it's similarly as well when you have issues like when you start talking about mold and the ventilation. These are really important things. And actually, to the point about lifestyle change, something that we're really thinking about at the moment is how we link retrofit to health and well-being, and again, comfort. That link isn't really strongly felt by many people, but I think increasingly we're recognising, we and others, that we need to sell retrofit on that as well, which may also help with the finance, which would be great.
That's the tricky argument, isn't it, in terms of selling it for security. It was quite interesting when we were doing our research on retrofit. We learned that people historically brought double glazed windows, went from single glazed to double glazed, not for the thermal efficiency, but for the security it provided from intruders. So, it's like kind of, what is that hook for retrofit? But what's very interesting in terms of what you mentioned is also there is a need to gather that data to test those solutions individually, but also a need to test them together and to gather the data on how they work together. So moving to Andy and Ethan, I mean, you've developed a solution that works together, that achieves interoperability. I always struggle with that word in the market. So how have you gone about doing that? And also, how is that space for being able to bring solutions that work with each other? How have you seen that change during your time in innovating for retrofit?
I'll hit Andy. How's that changed? So I suppose, I mean, my involvement has been from 2008. So back in like 2010, 11, 12, heat pumps did have a little bit of a raise in profile, if you want, and you had renewable heat incentive and Green Deal and some other government grants which kind of bring it into focus. And the question then was very much around, are they even viable? And the problem has been is that innovation as a word is effectively like a synonym for untested or, risky, effectively. Innovation is just used intermittently in a way. This is a very innovative product, basically means nobody uses it. So the danger with that is that then effectively in people's mentality, it discounts innovation because it boils down to risk. And, we find, I mean, basically the last 15 years has been absolute torture. It's like, when I don't know if any of you like into biking or whatever, but you cycle to the top of the hill and just as you get over the crest, it carries on. It's like that. You think, we've made it. Now we're being installed by Taylor Wimpey, we're being installed by Barrett Homes. You know, the product is on its way. It's on its way now. Here we go. We've got liftoff, and then you realise that there's another hurdle to come over, another hurdle to overcome, another hurdle to overcome, and that's fundamentally down to risk, I think. So now we are at crunch point where you have got legislative pressure coming from above, and I think I mentioned earlier is that the nearer you get to site, the greater the resistance to change gets. So, you know, I've worked with MCS, I've worked with or people at a government level, we've worked with architects, consultants, contractors, and then people on the ground, and then right the way down to your local plumber. And I've worked with all of them. And you get this momentum which just fizzles to nothing by the time you actually get to site. And the guy on site is going, why the hell am I installing a heat pump? There's nothing wrong with boilers. Boilers are great. Boilers are easy. They're really quick. So you have this like multi-tiered objection. And the problem is that somebody at the top makes the decision, we are going to do heat pumps, but it's somebody else's name against that specification that then says, for example, right, we're going to use Sunamp. You know, somebody at the table going, you sure we don't want to use standard water cylinder? No. Sunamp's on 35,000 systems. Okay, there's no need for testing. It's been tested. Thermoskirt, there's 85,000 thermoskirt systems out there, 17 years worth of data. If it didn't work, I wouldn't even be here. I'd have given up a long time ago. I'd have, you know, got into watercolour or something else. So the fact that those systems are tested, the issue that we run into, I'm sure you might run into it as well, Andy, is that you get a new client and it's like, well, let's run a pilot project. And it's like, oh my God, please, no, not another pilot project. Please, not another pilot project. It's been piloted. We'll take you to one down the street, you know. Oh, well, that's a different housing association, for example. So we are at that point now where there needs to be a little bit less risk aversion, I think, and construction in general needs to move away from the blame culture that it's somebody's fault. If it all goes wrong, who made that decision? They're fired. Because at the end of the day, nobody's going to innovate if the risk is they're going to suffer personally for it.
Yeah. Before I move to Andy, any reflections on why that inertia goes up as you move down the install chain?
I think it's perspective. So if you operate at a high level, it's like the same in business. I might explain to somebody on the staff why we're making a certain decision about this. They see it at a very granular level, and I see the 20-year picture. So, you know, they think, why the hell are we opening a distributor in Iceland? You know, because we're not even selling it in Sheffield. I'm looking, well, you know, they're using volcanoes to heat, you know, district heating systems that run at low temperatures and don't have radiators and you can't retrofit them. Like, I see that picture. And that's what happens is that as you move down the chain, people's nose basically gets closer and closer to the table. So eventually, like, they can't see why that decision is being made. They don't understand the point of it, and then they don't want to do it as a result.
Yeah,
that's why.
I will invite Laura and John's views on this later, but Andy, first to you on interoperability and kind of how you've seen interoperability either improve or become more complicated indeed, and how this innovation landscape is rapidly evolving.
Yeah, I sort of following on what you said about sort of bravery, technological innovation that we're ever doing. But we're on 5th generation product. To bring that up today to make it viable for retrofit, and like John was saying, if we look at each, you know, project individually and design that system around it, that's the approach we should take. I think the funding as well could do with sort of more flexibility in that legislation and where we fit in. I know at the moment we talk as Sunamp about a thermal battery or about a thermal store or a cylinder, and we don't necessarily fit into the right bracket to, you know, be viable or attract that funding, which I think that could be more flexible at some point to then, and like we've worked on projects with Ethan before where that collaborative approach, you know, the one system with the other system together could offer a solution for that project. So I do think collaboration is key, but also that flexibility on innovation, because we can react quite quickly, but we need the sort of legislation and regulation to flex as well, I think.
Yeah, that brings me, sorry, yeah, John, were you going to say something about that?
I'm happy. I mean, I think it's a really interesting subject, and it's really good to see Laura's feedback on the TSB work, because I was involved in doing a lot of going back and looking at buildings and how they performed in reality versus what we expected as architects in a previous life. And I think for me, as a person who is a designer who will be blamed, that is part of the culture if stuff goes wrong. I think it's important to have case studies and examples about how they work. So that the point being is, if it's 17 years of examples and you've got people like the TSB and that Innovate kind of proving case studies. So I think enhancing those case studies and sort of getting insurers to back it, often it all comes back to insurance in my experience, that basically if the insurers get funny about it, we can't do it. And even before the legislation, it's actually about the insurance. So I think we as architects often want to do stuff and want to push that boundary, but we need that surety. So I think, with both your products sound good, great. But I think for me, when we're specifying, choosing that technical design stage, it will be having some kind of getting kind of institutional backing, so that you can actually say, no, it's fine, guys, it's been installed for 17 years and it works.
Yeah, I will ask John one more question particularly around that deliverability, like being on the front, cold face of it, and workforce and skills. And plumber, you brought that up, right? It often comes up as a barrier. So what has been your experience when you are getting some of these innovative things delivered and on kind of having to deal with the people delivering it?
It's really hard. And
what do we do about it?
Yeah, I think education and skills and training is absolutely key. There were some other talks with the building centre about that, and we have an academy within our company where we bring in young people to kind of get that training and get architects back on the tools. So actually we go back and send our team into New City College to kind of do bricklaying and kind of different things, because we become quite detached from it. And I think there's such a great opportunity, and sometimes the government sort of supports it. Recently, apprenticeships have had a bit of money pulled away from them. But I think getting young people into kind of getting those skills, getting passionate about it, I think that's the only way. There's a huge amount of jobs out there, actually. I mean, one of the things you said about kind of heat pumps and boilers, I mean, why do a lot of people not want to install heat pumps? Because they don't really know how. A lot of it, there's still and there's loads of demand for it. So I think there's a big skills gap there. So I think it's sort of making the case for that and getting people out there and getting into training, and there's work, there's stuff to do.
I think that with traditional systems, they've been de-skilled to a point where that's why we've basically created a rod for our own back. Is that if you take a gas boiler, effectively, I'm not putting heat engineers down because I was one, but a trained chimp could do it. I was installing boilers when I was 19. It's 2 pipes in for your hot and cold, and 2 pipes in for your flow and return, and a gas pipe. So, I mentioned we sell into Iceland. In Iceland, if you want to be a heating engineer, it's 6 years at university. So you don't come out as a plumber, you come out, you know how to do heat loss calculations, flow resistances, pump speeds, back pressures, you've got full ability to do a detailed scoped design. And what happens is that because they've gone through that barrier, I suppose, that pain barrier of having to become heating engineers, they're very proud of it. So they come out like an architect would or an M&E consultant would. It's like, listen, I've done the hard yards at uni, all right? I'm now respected. It's a respected craft, and I'm really knowledgeable. So they throw themselves into innovation because they feel confident to deploy the knowledge that they've gained. And in the UK, if I wanted to be, if anybody in this room wanted to be a plumber, you basically need to go onto a company's house and pay a £12 registration fee and set up a plumbing company, because you don't actually need any qualifications to put 2 pieces of pipe together in the UK. So we don't have the skills in plumbing and heating to move to heat pumps, because it has been de-skilled to the point where it's, simple.
We're at time, so I will end it there. And I believe the panelists are around, so please do come and ask them questions if you have. And I'd please ask you to give Iceland panelists a round of applause.